This is my first video on this channel and it will go over functions and relations. My plan is to first create a series for college algebra. Okay, let's begin. In chapter 1 here, we will look at mathematical relationships involving two or more variables. To fully appreciate the connection among several variables, we will investigate their relationships algebraically, numerically, and graphically. The first section here is the rectangular coordinate system and graphing. Websites, newspapers, sporting events, and the workplace all utilize graphs and tables to present data. Therefore, it is important to learn how to create and interpret meaningful graphs. The Cartesian coordinate system, or the rectangular coordinate system, was developed by René Descartes. The coordinate plane consists of two perpendicular lines through the intersection point called the origin. It consists of x-axis, y-axis, and 4 quadrants. Ordered pairs describe the location in the coordinate system and are of the form x, y. As you can see in the figure here, we have this line which represents the x-axis. And here we have another vertical line which represents the y-axis. As you can see, x-axis and y-axis are perpendicular to each other. That means the angle between them is 90 degrees. We also see that they intersect at one point, which is 0, 0, and it is called the origin. Here we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This region where the x values are all positive and y values are positive is quadrant 1. The region where x values are negative but y values are positive is quadrant 2. The region where both x values and y values are negative is quadrant 3. And the region where x values are positive but y values are negative is quadrant 4. Here we have an example of -4, 3, which is called an ordered pair when you write it as x, y in bracket. So here we have -4, 3. So -4 corresponds to x and 3 corresponds to y. So how would you find -4, 3 on a graph like this? Let us do it step by step. We first go to x. Now we know that our x is -4. So this is x equals 0. This is x equals -1. This is -2, -3. And here we have -4. Let us draw a vertical line that goes through -4. Similarly, let's do the same process for the y. Here we have y equals 3, which is now here 0, 1, 2, and 3. Let us now draw a horizontal line that goes through point 3 on the y-axis. As you can see here, they intersect at this point, which is -4, 3, which shows the location of -4, 3 on this graph here. Okay, let us do an example. Let us plot these 6 points here. First, we have -1, 4. Point number 1 is -1, 4. So on the x-axis, this is 0. That is -1. So here we have, this is -1. Now we want y as 4. So you go y is 1, y is 2 here, 3 and 4, and you draw a horizontal line here. This intersection here is our first point, which is -1, 4. Similarly, we have next 3, 2. So on the x, it's 3. The point P2 is 3, 2. On the x, we have 3 here. So let us draw a line that goes through x equals 3. And then we have our y point as 2. This is 1 and 2 here. Let us draw a horizontal line that goes through this point. We have an intersection here again, and that is 3, 2. Similarly, we plot the other points. We have -4, 2. Here is -4. Here is our -2. The intersection here would be this point here. So that is -4, -2. All right. Next, we have 2, -5. So here we have 2, and this is -5. You find the intersection. This is 2, -5. Then we have 0, -3. So we are basically here on the y-axis. X is 0. This is our 0. And then we have -3, which is here. So this point is 0, -3. And lastly, here we have -4, 0, which will be on our x-axis since y is 0 and our x is -4, 0. So here, this is our point. Okay, let us move on. Now we will go over distance and midpoint formula. Recall that the distance between 2 points on a number line is the absolute value of the difference between the values a minus b. We can find the distance between 2 points on the coordinate system. The distance formula was derived from the Pythagoras theorem by constructing a right-angled triangle with the points x1, y1 and x2, y2, where the distance is the hypotenuse of the right-angled triangle. So here we have a right-angled triangle where the length of this side is A and the length of this is B. So basically this point here is x1, y1, and this point here is x2, y2. And we want to know what is the distance between x1, y1 and x2, y2. So if you see here, this is just a right-angled triangle with sides A and B, and now we want to know what this side is. As you know, the Pythagoras theorem, which is a squared plus b squared equals c squared. So we have same thing, a squared plus b squared equals c squared. And we want what c is. So c is basically root of a squared plus b squared. Okay. And we always want only the positive values because distance is calculated as a positive value. Okay, let us do example number 2 now. Let us first point 1, 2 and 4, 5, and then find the distance between them. 1, 2 is, this is x equals 1 here, y equals 2, and this is 1, 2. 4, 5, this is x equals 4, that is 5, this is 4, 5. Let me write them down here. So this is 1, 2, and this is 4, 5. We are now looking for the distance here. Since the question says that we have to use the Pythagorean theorem here, let us first create our right-angled triangle. which is basically just having a vertical line from here and a horizontal line here. The angle here is 90 degrees. So we know what this is, the length here, and we know the length here, and we want the length of this. So here basically we have x1 comma x2 as 4 comma 5. Sorry, x1 comma y1. x1 comma y1 as 4 comma 5 and x2 comma y2 as 1 comma 2. This distance here is 1, 2, and 3. So it's 3 units here. So let us call this side A, which is 3. And this side here, which is B, we can see here, we have 1, 2, 3. 3 units here. So we have A equals 3 and B equals 3. And we want to know what is C. As we formulated it before, C is square root of A squared plus B squared. So C is square root of A squared plus B squared, which is square root of 3 squared plus 3 squared, which is square root of 9 plus 9, which is root of 18. So now we know the distance between this point and this point. It is root 18 units. Okay. We will now go over the creation of the distance between two ordered pairs in the coordinate system. So here we have the distance formula. As we have discussed before, let us assume this equals A and this is B. We basically want the distance of this hypotenuse here, where this is a right angle triangle, and this would be square root of A squared plus B squared. If you look here more closely, this point here is denoted as x2 comma y2, and this point here is denoted as x2 comma y1. Essentially, these are our main points, and we want the distance between them. And we are trying to find the intersection if we draw a perpendicular line from both points vertically and horizontally. This is our intersection. As you see, it stays on the same y-axis at the same point, which is y1. That is why the coordinate system here has y1 for its y point. And here you see that it remains, the x is always constant on this line where x equals x2. That is why this point is x2 comma y1. Now, if we want the distance between here and here, this is basically saying you want to have this whole distance from here to here, which is x2, but you do not want this distance here, all of this. So what would you do is you would subtract this area, which is y1. Right, this one's y2. So this is essentially y2 minus y1 would give you exactly this area. The length of this line would give you y2 minus y1. Similarly, we follow the same thing here, where here you see this is x1 and this is x2. So we want the distance here. That would just mean you have x2, which is till here, and we do not want this region here. So that would mean we don't want this region, which is x1, and this whole thing is x2. So this region that we want here, the length of that line is x2 minus x1, which is B. So here we have A equals y2 minus y1. We say it's the absolute value just to make sure that we have the positive values where y2 is greater than y1. And then we have B as x2 minus x1, again, the absolute value. If you remember from here, we have C as square root of a squared plus b squared. So here we have A and B, and we need C, which is square root of a squared plus b squared, which is essentially square root of y2 minus y1 whole square plus x2 minus x1 whole square. I'm removing the modulus operator, this absolute value here, just because when you square it, no matter what this value is, be it positive or negative, it becomes a positive number, since multiplication of a positive and positive gives you a positive number, and multiplication of negative with a negative gives you a positive number as well. So this is the formula, as you can see here, where d is the distance of the hypotenuse here, is square root of the change in the x coordinate squared plus the change in the y coordinate squared. Okay. Yes. This is again the same formula, which is given here. And let us now find the distance between these 2 points using the distance formula. Here again, we have x1, y1 as 4, 5, and x2, y2 as 1, 2. From our distance formula, we have d is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Here x2 is 1, x1 is 4. This is 1 minus 4 whole square plus y2 is 2, y1 is 5. This is 2 minus 5 whole square. So here we have minus 3 whole square plus minus 3 whole square. Minus 3 times minus 3 is 9. Minus 3 plus minus 3 is 9 again. We have square root of 18. As you can see here, we got the same answer using both the methods. Okay. We will now move on to midpoint between 2 points. The midpoint of a line segment is the coordinate system. In the coordinate system is the halfway point between the 2 points. It is the average of the x values and the average of the y values. So basically, we have 2 points here. Let's call them x1, y1 and x2, y2. And we join them using a line segment. And we want to know what is the midpoint here. So this is basically saying that you're averaging your x values and you're averaging your y values to get your midpoint here. Okay, let us do an example to make it much more clear. Let us first plot these points, 3, minus 4. So this is 3 here, and this is minus 4. Their intersection falls here. So this is 3, minus 4. Then we have minus 1, minus 1. So this is minus 1 here, this is minus 1. The intersection falls here, minus 1, minus 1. We want to know the distance between these points and the midpoint would be somewhere here. You can find the distance in two different ways. You can either do it using the Pythagoras theorem, where this is your A and B, and you find C, which is square root of A squared plus B squared, or you can just use the distance formula. Here I'll be using the distance formula. Let me write down my points again. We have x1 comma y1. Let me write it neatly. We have x1 comma y1 is 3 comma minus 4, and x2 comma y2 is minus 1 comma minus 1. As you recall, the distance formula is the difference between the x coordinates squared plus distance between the y coordinates squared and rooted. So here my x2 is minus 1, my x1 is 3, and my y2 is minus 1, my y1 is minus 4. So we have minus of minus 4 then squared. Here we have minus 1 minus 3, which is minus 4 whole square, plus, as you can see here, you have minus 1, minus times minus gives you a plus. It's minus 1 plus 4 whole square. And then this would be minus 4 whole square plus 3 square, which is 16 plus 9, which will give you root 25, which is technically plus or minus 5, but here we are talking about distance, which is always positive. So we just write it as 5. So the distance is 5 units. Right. Let us now find the midpoint. I will erase this really quickly. Right. As I mentioned before, the midpoint is basically the average of our x values and average of the y values for the y coordinate. So let's call the midpoint x3 and y3. So x3 is the average of x1 plus x2 by 2, and y3 is the average of y1 plus y2 by 2. x1 is 3 here, plus x2 is minus 1, then you do divided by 2, comma y1 is minus 4 here, and y2 is minus 1 divided by 2. Just some arithmetic here. We have 3 minus 1 is 2 by 2. You have minus 4 minus 1, which is minus 5 by 2. So this is 1 comma negative 2.5. So let us try to plot this, which is, this is 1 here. Let me draw a vertical line. We have negative 2.5 as our y coordinate. So it would possibly be somewhere between here. Let me draw a horizontal line. This is the intersection. As you can see, it's very similar to where we initially just approximated and put a point, just averaging like in our head, just trying to see where the midpoint could be. And we see that this point here is the midpoint, which is 1 comma negative 2.5. Okay. Let us now do another example. This is a little bit different. So here we are given the midpoint. which is minus 5, 7, and we are given one of the points, which is minus 9, 6, and we want to find the other point. So basically, let's write our formula again. We have x3, y3, which is our midpoint, is basically the average of x coordinates and the average of y coordinates. So here we know what x3 and y3 are. We are given that x3 and y3 are minus 5, 7, right? And then we are given x1 as minus 9, and we don't know what x2 is. Let us write down it as x2. And then we are given what y1 is, which is 6. We don't know what y2 is, and we have divided by 2. Okay. So one thing is, as you can see here, the x coordinate, we have an x coordinate here, we have y coordinate, and we have a y coordinate here. And they are, the operator here is equal to. So this means that minus 5 here is equal to this, and minus 7 here, sorry, positive 7 is equal to this. Let us write down using linear equations here, where we are just saying that our minus 5 is equal to minus 9 plus x2 over 2, and 6, this is 7. Then we have 7 equals 6 plus y2 over 2. And we are here looking for x2 values and y2 values. Okay, let us first solve for x2. Let me write it down again. We have minus 5 equals minus 9 plus x2 over 2. First step would be multiplying both sides by 2. I'm multiplying this by 2 and this by 2. So here, 2 and 2 gets canceled, and we are left with minus 10 equals minus 9 plus x2, and x2 equals minus 10 plus 9, which is minus 1. Similarly, let's follow the same steps for y2 here. We have 7 equals 6 plus y2 over 2. We first multiply both sides by 2. 2 gets cancelled. We have 14 equals 6 plus y2. Then you subtract 14 from both sides. Then you have 14 minus 14 equals 6 plus y2 minus 14, which is 0 equals minus 8 plus y2. And y2 equals 8. You get this by adding 8 on both sides. So here we have our coordinate. Our x2 is minus 1 and y2 is 8. So the point P2 here is minus 1, 8. That is our answer. Let's do one more example. Where we are finding the distance and the midpoint of the segment below. So in this figure here, you can see that we have a circle where one of the points is minus 3, 4, and the other point is 5, 6. We follow the same steps as before for finding both the distance and the midpoint. This time I will do it a little more quickly. Let me write down the points first. We have x1, y1 as minus 3, 4, and x2, y2 as 5, 6. I will be using the distance formula again, where d is square root of our distance between the x coordinates, which is, and then squared, plus distance between the y coordinates, squared, and then you have the whole root, which is equal to 5 plus 3 is 8, and 8 squared is 64, plus 6 minus 4 is 2, and 2 squared is 4. So we have root 68. Similarly, let's find our midpoint. Midpoint basically is the average of the x coordinates and the y coordinates. So here we are trying to find x3 comma y3 is average of x1 and x2, which is minus 3 plus 5 over 2, comma the average of y1 and y2, which is 4 plus 6 over 2. 5 minus 3 here is 2. So we have 2 by 2. And here we have 6 plus 4 is 10. So 10 over 2. 2 by 2 is 1. 10 over 2 is 5. So that is our midpoint. As you can see, it would lie somewhere here. And that is on the line where this is 1. And this is 5. So here our midpoint is 1 comma 5. And our distance is root 68 units. Okay. Okay, so the next section here is graph equations by plotting points. Since a graph represents the solution of an equation, we can always determine the graph by finding some solution points, graph them, and connect the points. Here we use the t-table, x and xy table, to help us. So here we want to graph the equation y equals 3x minus 5. Let us first find some points where what happens at different y's and what happens at different x's. What I normally do is I find what happens at x equals 0 and 2 points in the negative side and 2 points in the positive side. Let us do the same thing here, where I will find what happens at 0, at 1, at 2, minus 1, and minus 2 for x values. So let us find that out first. When x equals 0, y is basically 3 times 0 minus 5, which is minus 5. When x equals 1, we have 3 times 1 minus 5, which is 3 minus 5 is minus 2. And at 2, we have 3 times 2 minus 5, which is 6 minus 5 is 1. Then we have 3 times minus 1 minus 5. Sorry, minus 1 minus 5. This 3 times minus 1 is negative 3. Negative 3, negative 5 is negative 8. And then we have 3 times negative 2, negative 5, which is 3 to 6. So this is minus 6, minus 5. Minus 6 minus 5 is minus 11. So if you see here, we basically found 5 different coordinates. So we have first coordinate here is 0 comma minus 5. And then we have 1 comma minus 2. We have 2 comma 1. We have minus 1 comma minus 8. And we have minus 2 comma minus 11. Okay, let us now plot these points here on the graph. 0 comma minus 5, that is 0, 1, 2, 3, 4, 5 in the negative direction. So that is our first point. And then we have 1 comma negative 2. So this is 1 here, and that's negative 2. And then we have 2, comma 1. So this is 2, and that is 1. And then we have -1, comma -8. This is -1 here. Give me 1, 2, 3, 4, 5, 6, 7, 8. So that is first point. And then -2, -11. This one -2. As you know, this one was 8, 9, 10. So it is somewhere here. Let me cross check if we got everything right here. We have 3 times 0. -5 is -5. 3 ones 3 minus 5 is -2. 3 to 6 minus 5 is 1. -3 minus 5 is -8. And 3 times -2 is -6. This is -11. So all you have to do now is join these points here. And this is our line that we're looking, which is 3x minus 5 equals y. This is the line y equals 3x minus 5. Okay, let us plot another graph. Here you see that this is a linear equation, and this is a quadratic equation. I will go over what linear and quadratic are in the upcoming videos. For now, let's just accept that this is a quadratic equation and that is a linear equation. Here we have y equals minus x squared plus 4. Let us do the same thing where we have 0, 1, 2, -1, -2. So when x is 0, we plug in x equals 0 in this equation, and then we get a 4. Then we plug in x as 1. So here we have x as 1. So this is -1 squared plus 4, which is 4 minus 1 is 3. When it is 2, we have -4 plus 4, which is 0. Let me erase this. And then when we have -1, we get the same values as 1 because we are squaring it. So when you square a number, no matter what, it's positive or negative, the answer is always positive. So when you plug in -1 instead of x here, you still get -1 plus 4, which is 3. And for -2, you get -4 plus 4, which is 0 again. So here, the first coordinate is 0, 4. Let us plot that. That is 0 and 1, 2, 3, 4. So that is 0, 4. And then we have 1, 3. This is 1. 1, 2, 3 here. And then we have 2, 0. So this is 2 and that's 0. Same thing. We see that it's very symmetric here. And 2, the -1, this is -2. And then now we join the points. Oops. We have it here, here, and here. And then we join the points. And this is the equation, this is the graph, sorry, for y equals -x squared plus 4. So we plotted 2 graphs so far, a linear equation here, a quadratic equation here. And let us do this last one, where y is the absolute value of x minus 2. One thing to recall is absolute value of a positive number is a positive number, and absolute value of a negative number is a positive number. So here, same thing again, we find for 0, 1, 2, -1, and -2. So this would be modulus 0 minus 2. This would be 1 minus 2. be 2 minus 2. This will be negative 1, negative 2, and negative 2, negative 2. The absolute value of negative 2 here is 2. The absolute value of negative 1 is 1. The absolute value of 0 is 0. The absolute value of negative 3 is 3. The absolute value of negative 4 is 4. So here we have when x is 0, y is 2. So this is our first point. When x is 1, y is 1. When x is 2, y is 0. When x is negative 1, y is 3. When x is negative 2, y is negative 4. So here we have this as our graph. Let us do one more point and see what happens at x equals 3. So when x equals 3, y equals modulus of 3 minus 2, absolute value of 3 minus 2, which is 1. So at x equals 3 here, we have y is 1. So you see that it's like a V here, and it keeps going that way. So one thing is also to realize is sometimes when you find the y values for very few x values which are really close, you don't know how they behave in the long term. So sometimes it's also good to plot some extra points to just make sure you know the direction of your graph here. Okay, the last topic here we have is the intercepts. So intercepts are points where the graph crosses the x-axis and the y-axis. We have x-intercept and y-intercept, where x-intercept is the point where the graph crosses the x-axis. That is, which point, what happens to x when y is 0. And then we have y-intercept, which is the point where the graph crosses the y-axis. That is, what is the y value when x is 0? As you can see here in this graph, we have, this is our y-intercept and this is our x-intercept. We see that here, this point is where the graph crosses our y-axis, where this is our y-axis and this is our x-axis. And x-intercept is where the graph crosses our x-axis. So as you know, this point here is 0, y, because x is 0 and y is the one that's changing. And this point is x, 0, as y stays 0 and x is the one that's changing. Let us do an example where it says, from the previous graphs, identify the x-intercept and y-intercept if they exist. Okay, let us find in this graph first. So here we see that at this point, the graph, the line here, it crosses our x-axis. So this is the x-intercept. And here at this point, it crosses the y-axis. So that is the y-intercept. So here you see this, when x is 0, what is y? That is 0, minus 5. So you have 0, minus 5 as your x-intercept. Sorry. This is the y-intercept because x is constant and y is changing. As you can see in the definition here, the point where it crosses the y-axis. So x is 0, but y is changing. That is what is happening here, where x is 0 and y is changing. And the x-intercept here, we don't exactly know what the value is, so let us find out. So we want to know what is the value of x when y is 0. So let us plug in, instead of y, we have 0 now. So 0 equals 3x minus 5. Adding 5 on both sides, we have 5 equals 3x, and x is 5 over 3. So our x-intercept is 5 over 3, 0. This is our x-intercept. Similarly, in this graph here, this is our y-intercept, because that is where it crosses the y-axis. And you can see here that we have two x-intercepts. We have one x-intercept here and here. From this table here, this is the y-intercept. And these two here are the x-intercepts. Same thing here. This point here is, let me erase this. So this point here is our y-intercept. And here you see that it never crosses the x-axis. But let us see if it ever happens that x is 0 and, sorry, y is 0. So when y is 0, we have 0, x minus 2. Just x minus 2 equals 0. So x is 2. So our x-intercept, oh yeah, it's here, is when x is 2 and y is 0. This is one of the x-intercepts. This 2, 0. And our y-intercept is 0, 2. This is our y-intercept. Right. So in the next video, I will be covering circles, essentially the equation of the circle, what is the center, radius, and some formulas that are related to center, radius, and the equation of the circle. Okay.